I'm out in the shop at Forest Concepts today. Let's talk about particle size and particle size distribution. Particle size can come in qualitative forms, small, medium, large, or quantitative forms like 8 millimeter, 6 millimeter, 1 inch. But that's only half the story. Not only do you have a particle size, but you have a distribution. I'm a mechanical engineer, so I relate a lot of things back to automobiles. Let's say you're driving down the road and you're looking out your windshield and you see a car. Well, there's lots of different sizes of cars that you might be seeing. You might be seeing a little Honda Civic or a large F-150 or even bigger, a semi-truck with a trailer. That range of sizes that you're looking at for automobiles is called a distribution. So when we look at wood chips or biomass, doesn't have to be a wood chip. For example, I've got several different sizes right here of just a generic wood chip. This could also be a wood chip. I have several more sizes. Now, within the grouping, there's more than one size, so we call that a distribution. The bigger the size difference between the smaller and the bigger particles within a group means a broader or wider size distribution. The tighter the group is, the narrower the size distribution. Now, why do I care about that, or why do you care about that? If you are processing biomass and you are going into, say, some downstream chemical conversion process, maybe you have to dry it first. Small particles dry at a different rate than a large particle. You can think about this like cooking a cake or a cupcake. If I take my cupcake and I put it in the oven, it will cook faster, or it will be done in the center faster than a large cake in the oven, because it takes more time for the heat to be able to get in from the outside to the center of the cake than it does to the center of the cupcake. Similarly, it takes more time for the moisture in the middle of the cake to make its way to the outside to be evaporated off to where you have that delicious cake at the end of the day. When we're going into a dryer, it's the same kind of idea, to where distance to center makes a difference for how long the particle has to be in the dryer. The shorter the residence time, the less energy it takes. Therefore, it's a more efficient process to be able to dry smaller particles than it is larger particles. You'll see on your screen these curves that show a narrow or tight particle size distribution. That means that you have more consistent and more uniform drying happening when you're going into the dryer. You don't have some particles coming out under-dried and some over-dried. Beyond that, downstream of a dryer, you might be going into a thermochemical conversion process. You may be in a reactor downstream of that dryer where you're looking at, say, making renewable diesel out of a wood chip or out of corn stover. The consistency of the chemical reaction is dependent on the consistency or the uniformity of the particle size. You want that tight particle size distribution to be able to get the same hydrocarbon chains coming out, as opposed to a flat or a wider size distribution. Because just like how the cake and the cupcake cook differently, the chemical reaction is at different spots in the process between the large chip and the small chip. Now, another way that particle size distribution can come into play is aspect ratio. I have long pieces, I have short pieces. High aspect ratio means long length compared to short width. Low aspect ratio is about the same length or to the same width. So 1:1 is a 1:1 aspect ratio. Let's say this is 7:1, that's a 7:1 aspect ratio. So the tighter or the smaller the aspect ratio, the better the material flows. So if we move this over here and I bring some of my other sample materials out, I have material A here This happens to have been produced in a rotary shear or a crumbler by Forest Concepts. This is material B, produced in a hammer mill. The size reduction process or mechanism makes a difference in how the material geometry comes out. Both of these materials have the same nominal particle size. So the center of the peaks are about the same spot. This has a tighter or a narrower particle size distribution, while this one has a wider or a broader particle size distribution. So we talked about drying, but now what about material handling? Aspect ratio makes a difference. So if I take my little simulated hopper, I try to open at about the same width. In fact, we'll come up closed, and I open, low aspect ratio material flows quickly. If I go to my higher aspect ratio, trying to keep that similar slope as my initial one, and I open up, you see it bridges or it crosses. I can help increase my angle, and I'm still bridging. I have to get a bigger and bigger opening before material flows out. So running high aspect ratio material can plug up your auger reactors. It can plug up some of your transition points at your different points in your material handling system, and it can plug up your feed hoppers. So your feed hoppers have to be designed specifically to be able to deal with these less flowable materials. Whereas conversely, I can take my high flowability, my low aspect ratio materials, and be able to feed my downstream processes, not plug up my auger, not plug up my transition points at my conveyors, and not plug up my my hoppers. So at the end of the day, why does this matter to you? Not jamming up your equipment saves a lot of money in your operational procedures. Every time you have to shut down your facility to unplug a reactor, to unplug an auger, to unplug a transition point, costs you. So we want a low aspect ratio material. Similarly, there have been studies that have shown that by doing size reduction and getting a high uniformity material before you go into a dryer can save you 50% of your drying energy. Drying energy is one of the major expenses in a biomass processing facility that requires a dry material. Therefore, low aspect ratio, tight particle size distribution is much preferred in your process. If you want consistent drying, free-flowing reactors, and to eliminate material handling problems, give us a call at the number on your screen or visit our website at forestconcepts.com.